Hey again, everyone. I had originally planned on this being a different video, and as usual, it's taken me a lot longer than I had hoped to put it together. What I wanted to do was a deep dive into the few offerings of Tortoise TTS out there, but I hit a few walls along the way. Random errors, broken dependency chains, very slow performance, Git repositories going offline repeatedly, and shrinking drive space as I reinstalled means. It's going to be a different video now. I ended up having to back up the files on one of my WSL-Ubuntu installs and redoing it, so today I'll be going through that first. Then I'll go over getting the original Tortoise TTS release up and running, and take a look at the AI Voice Cloning GUI.
To keep the run time of this down, rather than large sections where I play samples generated with Tortoise, I'll use Tortoise to re-record some of my narration.
I'm not cherry picking samples for this, and I'm not making any special effort to dial in optimal settings.
This is just going to be out-of-the-box performance. The spoken audio may have weird affectations, accents, or other aberrations, and I'm leaving it all in.
I'm running this on an i5 8400 CPU, which I believe is a 6-core 2.8 gigahertz CPU. The board is maxed out at 32 gigabytes of RAM, and the GPU is an NVIDIA RTX 3060 12GB card. There are too many orphaned packages and random junk in my current install of Ubuntu, so the first thing I'm going to do is get rid of it by removing the entire installation.
A word of caution before you begin.
This will delete the entire file system, and it can't be recovered, so be sure to back up what you need.
I backed up my files already, so I'm going to go ahead and delete the WSL Ubuntu and then reinstall a fresh copy. To do that, open up a console window with administrative privileges and type WSL-L to list installed distributions. Type WSL-unregister and the name of the installed distribution to remove it and its file system. Next, I'm going to reinstall WSL Ubuntu 20.4. Type WSL-install-d Ubuntu 20.04, and when it's finished, you'll be asked to create a user and password. I'm going to update the package list with sudo apt-get and upgrade packages with sudo apt-upgrade. I want to keep most things contained within a Conda environment when I play with new software. Go to the Anaconda site, find the Linux download URL, and copy it. In the Ubuntu window, download the package with wget and the URL. Type chmod plus x and the package file name to make it executable. Run the file with // and the package file name.
Accept the agreement, install Conda, and type yes to initialize the environment.
I want to be able to use GPU acceleration, so I'll need to install the CUDA libraries and CUD in it. Since it may offer a performance boost and it should be backward compatible, I'm going to use CUDA 11.8 rather than 11.7.
The CUDA install commands used here are listed down below and come from the NVIDIA CUDA download page.
After setting up the downloaded package, run sudo apt-get update and sudo apt-get -install CUDA to auto-accept all of the input prompts.
You may have noticed that during the apt update, there were a couple errors at the end of the process.
Linux expects a couple of libraries to be symbolic links rather than actual files.
The process to fix this is a little convoluted and takes a few steps.
I have put these steps down in the description so you can check later.
Open a Windows shell with administrative privileges. Then, change directories to your Windows install directory, system32/lxsss/lib. Move libcuda.so to libcuda.so. And move libcuda.so.1 to libcuda.so.1.back. Close any active WSL sessions by typing WSL-shutdown. Type WSL-e/bin/bash to load a Linux shell in the Windows directory. Create the expected symbolic links with ln-slibcuda.so.1.1 libcuda.so.1
and ln-slibcuda.so.1.1 libcuda.so. Similarly, move or remove libnv-optics.so.1 and link it to libnv-optics_loader.so.1. Type ld config to reload the libraries, then type exit, or in a Windows console, type WSL-shutdown. Now, I'll restart the WSL Ubuntu install and finish setting up CUDA. I'm going to set up the base system with CUDA 11.8 with the base environment active, type Conda Install -c Conda-forge CUDA toolkit equals 11.8 and then CUDNN to install the CUDA toolkit and appropriate CUDNN version. With the CUDA setup out of the way, I'll get Torch installed on the base environment. This will cache the packages, making it fast to make any new environments that also use that Torch version. You can skip doing this here if you like, and just install whatever version of Torch is required for the packages you're using when you make a new Conda environment. The command up on the screen installs the current Torch version and associated packages built with CUDA 11.8 support. As of this video, Torch has released version 2.0. Change the number at the end of the URL in the command line to specify your desired CUDA build version. When you're done configuring the system, you can create a complete backup that can be easily restored if your original becomes too messy. Open a Windows command prompt with administrative privileges and type WSL-L to list install distributions. Type WSL-shutdown to close any active installs. To create a system backup, type WSL-export, then the name of the distribution, then the location and file name of the image.tar. The configuration is mostly out of the way, so I'll get on with installing Tortoise TTS. I've created a new Conda environment using the command conda create-n tortoise, which is the environment name, and then Python equals 3.9 git pip. And activated it using conda activate tortoise. Clone the Tortoise TTS GitHub repository to your system using git clone and the URL. Change to the directory the repo was cloned into. Normally, you could simply run pip and tell it to use the requirements.txt file to install package requirement. Unfortunately, the dependencies seem to be a little broken for Tortoise TTS. It looks like the incorrect SciPy version is installed, and a few other package versions cause conflict. After some fiddling around, I think I have versions that work well together, so I'll link a modified requirements.txt in the description. Or you can pause the video and get the changes from the screen. With the Conda environment active and after selecting alternate package versions, install the requirements with python-m pip-install-r requirements.txt. Then, install Tortoise TTS with python setup.py install. Generating text with Tortoise, as the name suggests, is very slow in comparison to other TTS models. It is difficult to provide benchmarks for the performance, as it differs wildly between hardware configuration, model loading options, generation parameters, and sentence structure. It takes somewhere between 90 seconds and about 4 minutes to generate a sentence on my system using the fast preset. Tortoise is set up with several quality presets which are used to select the parameters used in the backend. This is a diffusion-based model, so output results are not uniform between generation runs by default. Similar to stable diffusion, the user can set a seed to try to generate the same output in the future. The ultra-fast setting is more prone to aberrations and noise, which means you may need to rerun your generations occasionally to get decent output. The fast preset uses more samples and iterations and generally produces output that sounds clear and realistic, depending on the original voice samples used or the random voice generated. I have not been able to use the high quality preset because it places a huge load on my GPU and runs for a very long time. Frankly, I'm not willing to burn out my GPU running it for an hour to generate one sentence. Check the Tortoise TTS GitHub page for detailed use instructions for the command line application. There is also a read.py script that can be used to turn large sections of text into speech, and a Python API if you want to integrate Tortoise with other scripts. Using the zero-shot voice cloning capability of Tortoise TTS is relatively simple. Resample audio clips to 22 kHz WAV files and put them in the Tortoise/voices subdirectory and inside a subdirectory named after your voice. Use the flag --voice and the name of the voice directory containing your audio samples.
A lot of the parameters to adjust Tortoise TTS generations are behind those preset settings and can be adjusted if you use the Python API. The original Tortoise TTS code was forked some time ago into what seems to be two main projects, the Tortoise TTS-Fast project and the AI Voice Cloning GUI. Both seem to offer some sort of speed increase over the original code, at least in many cases. The Tortoise TTS-Fast project is no longer being updated and does have a few issues, but I'll go over those later. First, we'll look at the AI Voice Cloning GUI. I'll go through the installation, briefly poke around the interface, and talk a little about fine-tuning or training the Tortoise TTS models. This is going to be a surface-level look. There are a lot of knobs that can be fiddled with in the GUI, and subtle changes to parameters can lead to huge changes in output, but often that is very dependent on the input. Let's go through the installation of the AI Voice Cloning GUI. Clone the project's GitHub repo with git clone, then change to the AI Voice Cloning directory. Make the shell scripts executable if they aren't already with chmod +x star.sh. If you've already created a Conda environment for the official Tortoise TTS install, you can probably use the same environment for the voice cloning project. I'll create a new environment here, but on my system, for general use, I do have both in the same environment. Create a new Conda environment with Conda, create -n, the environment name, and Python equals 3.10.6 git pip. Activate the Conda environment with Conda activate and the environment name. Run the setup -cuda-wsl shell script to install all of the dependencies and the project. Once it has installed, launch the web UI with /start.sh, and in a browser, go to the URL shown in the console window. There are a lot of knobs that can be fiddled with in the GUI, and subtle changes to parameters can lead to huge changes in output, but often that is very dependent on the input. So, it's difficult for me to say how a particular voice is going to respond to any of the parameters being changed. For simply generating text, I'd suggest trying to stick to the default parameters, and if you're not satisfied with the output quality, first adjust the number of and quality of your input samples. It's easy to get into the weeds obsessing about minute parameter changes, and they often don't carry over between different voices or fine-tuned models. Lowering the length penalty tends to generate slower output. Increasing the repetition penalty can reduce repetition errors in the output, which is common if you use the same word twice, such as dash dash, 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 dash. The temperature can be used to adjust the amount of vocal affectations and noise in the output. If this is set too low, the speech tends to sound very robotic and monotonous. To use zero-shot voice cloning, place your audio samples in a subdirectory of the Tortoise directory with your voice name. I believe the script will convert the audio files to the appropriate input format, but I tend to convert all of mine to 22 kHz single channel wave files first. I'm not sure if that matters though. Refresh the voice list and select your voice, then enter your input text and click generate.
The script will take some time on the first generation to compute latents from your audio files, but will be faster on subsequent generation. There may be a few bugs in the script, such as the stop button seems to be non-functional. You can terminate the script with Ctrl+C in the console window and reload if you find yourself waiting too long for speech generation. You can attempt to apply emotional affectations to your speech using the presets. These add a prefix to your input text which is processed but not spoken. To attempt to apply your own affectations, place the emotional trigger prefix text in square brackets. Things like, I am so happy, I am angry, I am sad tend to be effective. I'm going to skip playing example generations because you've been hearing them this whole time and move ahead to fine-tuning a model.
I haven't done enough training with this to definitively state what are good parameters, and there is a very detailed wiki site that can help you figure out your way around the training section, but I'll share a little about my training experiences. I won't go into gathering or pre-processing samples here, because I cover that quite a bit in my other TTS videos, and the project's wiki has a section about it. Gather your samples, somewhere between a few dozen and several thousand, and place them in a subdirectory of the voices directory, the same place you would place them for zero-shot voice cloning. Click Refresh Voices on the main page, and then open the Dataset tab. Select the voice from the drop-down list. If the samples are longer than 10 seconds, click Slice Segments. If you have leading silences, click Trim. Select the whisper model you would like to use for transcription in the box at the bottom of the screen. The voice cloning UI supports a few whisper backends, but the only one installed by default is OpenAI's Whisper. Eventually, I may get around to adding the Whisper Fast backend here and share how to do it, because it does work a little faster than the basic Whisper, but so far I haven't had it work consistently yet. You may need to open the Settings tab and select Do Not Load TTS on startup, and then restart the WebUI before. Sometimes the TTS model fails to unload, and the Whisper model loading will cause out-of-memory errors. The smaller models operate faster and use less memory, but offer simpler and potentially less accurate output. Check the OpenAI Whisper Speech to Text GitHub page to see the capabilities of each model. Click Transcribe and process to do just that. Whisper takes quite a long time to transcribe clips, but thankfully, if the session is interrupted, you can select the Skip Existing option, and clips with existing transcriptions will be skipped. Under the Generate Configuration tab, you can set training parameters. The default options seem to be a good starting point. If you use half-precision training here to attempt to reduce VRAM consumption, you will need to use half-precision on loading and generating with the model. The batch size and grad accumulation will auto-balance. Select a batch size like 128 or 64 and click Validate Configuration. The script will examine values and correct anything that it thinks is outside of a reasonable range. If you can, it's probably a good idea to use bits and bytes for training, so you can use much larger batch sizes. Each save state and model checkpoint are together about 2 GB, so be aware of how many checkpoints you'll be saving during your training session. You can burn through drive space really quick. After setting training parameters, click Save Training Configuration and open up the Training tab. Select your saved configuration from the drop-down. Click Train to begin, and you'll be able to see live-updating training graphs in the browser. Whatever you do, don't click the thing that says Training Metrics. For whatever reason, at least on my system, it causes the training session to break and the script to crash. If you want to resume a previous training session, under the Configuration tab, select the checkpoint in the source model and enter the path to the saved state under the Resume State path. Click Reuse or Import Dataset, then proceed to validate and save your training configuration and train as before. Go to the Settings tab, click Refresh Models, and then select your fine-tuned diffusion model from the list to load it. On the Generation screen, select the voice you want to use from the Voices drop-down and enter your text and settings as usual. You will need to wait for the script to recompute the latents again, but you should be able to get speech that sounds a little more like the desired speaker using fine-tuning. Review the wiki for recommended training settings, but they seem to be very data-dependent. Expect to do a little bit of fiddling with dataset size, number of epochs, and if you are using a small batch size, like 32, you may need to lower the learning rates. When it comes down to training or fine-tuning, essentially, you'll just have to try it out and see what works best in your situation. But the GUI does make it fairly easy to do. I want to mention one last project, the Tortoise TTS-Fast fork. This project is no longer being updated, but has a few tweaks that may offer faster generations. It's tough to say how much, but somewhere between 2 and 10 times. I'm not going to go through the installation of the Fast fork, as it's very similar to installing the others. Just follow the instructions on the GitHub page. One main issue I've noticed with the Fast fork is that the outputs in the results folder don't have their file names iterated to increase the digits when they're saved. So, if you generate a second sample, you'll overwrite the first. Other than that, the Fast fork seems to generate speech about twice as fast as the AI voice cloning GUI on my system. Tortoise is a very interesting TTS project that can really inject some lifelike sounds into generated speech. While it may not be appropriate for real-time applications, the nearly true-to-life sounding voices make it worth a look for those doing artistic projects. That's about all I can cover today. If you found this video helpful, please hit the subscribe button so YouTube will share the videos out to more people. Thanks for watching.